Welcome to our channel. Today we're diving into the incredible world of advanced robotics and automation. From intelligent machines that can think and learn, to robots that perform delicate surgeries with precision, this technology is transforming our world in ways we never imagined. Join us as we explore how these cutting-edge robots are revolutionizing industries like manufacturing, logistics, healthcare, and agriculture. We'll also discuss the ethical and social implications of this technological leap. The field of advanced robotics and automation is at the forefront of technological innovation, blending robotics, artificial intelligence, AI, and other advanced technologies to create intelligent machines that can perform tasks autonomously. These robots surpass traditional industrial counterparts in sophistication, capability, and adaptability, opening up new possibilities across various sectors. Here are the key features of advanced robotics and automation, their impact on different industries, and the ethical and social implications of their development and deployment. Key features of advanced robotics and automation. Number 1. Intelligence. Advanced robots are equipped with AI and machine learning algorithms that enable them to perceive their surroundings, understand complex instructions, and make decisions based on real-time data. This intelligence allows robots to learn from their experiences, improve their performance over time, and adapt to new and unforeseen situations. For instance, machine learning algorithms can enable a robot to recognize and categorize objects, navigate through dynamic environments, and even predict the best course of action in complex scenarios. Number 2. Dexterity. Dexterity refers to the robot's ability to perform delicate and precise tasks thanks to sophisticated grippers and manipulators. These advanced end effectors mimic the dexterity of the human hand, allowing robots to handle fragile objects, perform intricate assembly tasks, and conduct delicate operations such as surgery. The development of soft robotics, which involves the use of flexible and adaptive materials, has further enhanced the dexterity of robots, enabling them to interact safely and effectively with a variety of objects and environments. Number 3. Autonomy. Autonomous robots operate independently, using sensors and algorithms to navigate and respond to their environment without ongoing human supervision. These robots can be programmed for specific tasks or use sensors to adapt in real time. For instance, autonomous mobile robots, AMRs, in warehouses navigate around obstacles, optimize their routes, and collaborate with other robots to ensure efficient operations. Their ability to autonomously adapt to dynamic environments makes them ideal for tasks requiring flexibility and precision. This technology significantly enhances productivity and efficiency in various sectors, from manufacturing and logistics to healthcare and agriculture, demonstrating the transformative potential of autonomous systems in automating complex processes and improving overall operational effectiveness. Impact on various industries. Manufacturing. In manufacturing, advanced robotics and automation are revolutionizing the production process. Robots are increasingly being used to automate repetitive and hazardous tasks, such as welding, painting, and assembly. This automation leads to increased productivity, efficiency, and consistency in product quality. Collaborative robots, or cobots, work alongside human workers, enhancing their capabilities and allowing for more flexible and efficient production lines. The integration of AI and machine learning in manufacturing robots also enables predictive maintenance, reducing downtime and improving overall operational efficiency. Logistics. The logistics industry is experiencing significant transformation through the deployment of advanced robotics. Autonomous mobile robots, AMRs, are used in warehouses and distribution centers to transport goods, sort packages, and manage inventory. These robots improve logistics efficiency by optimizing routes, reducing manual labor, and minimizing errors. For instance, AMRs can navigate through complex warehouse layouts, avoid obstacles, and collaborate with human workers and other robots to ensure seamless operations. The use of drones for last-mile delivery is also gaining traction, promising faster and more efficient delivery services. Healthcare. In healthcare, advanced robotics are enhancing the precision and accuracy of medical procedures. Surgical robots, such as the Da Vinci surgical system, allow surgeons to perform complex surgeries with greater control and precision than traditional methods. These robots provide high-definition 3D visualization and enhanced dexterity, leading to smaller incisions, reduced blood loss, and faster recovery times for patients. Beyond surgery, robots are also used for tasks such as patient monitoring, drug dispensing, and rehabilitation, improving overall patient care and outcomes. Agriculture. The agricultural sector is leveraging advanced robotics to address labor shortages and improve productivity. Autonomous tractors and agricultural robots are used for tasks such as planting, cultivating, and harvesting crops. These robots can operate around the clock, monitor crop health using sensors and imaging technologies, and apply precise amounts of water, fertilizer, and pesticides, reducing waste and enhancing yields. For example, robotic harvesters can pick fruits and vegetables with minimal damage, ensuring higher quality produce and reducing the reliance on seasonal labor. Ethical and social implications. Advanced robotics and automation, while beneficial, raise significant ethical and social concerns, notably job displacement, privacy, bias, and safety. Robots replacing human jobs in industries like manufacturing and agriculture necessitate substantial investment in education and training for workers to transition to new roles in robotics-related fields. The potential for privacy infringements and security breaches from data collected by robots, such as healthcare robots accessing patient information, demands robust data protection measures. AI biases, stemming from biased training data, can lead to unfair outcomes in areas like hiring and law enforcement, necessitating efforts to ensure diversity and fairness in AI development. Ensuring the safety and reliability of autonomous robots in critical sectors like healthcare and transportation requires rigorous testing, validation, and regulatory frameworks to prevent accidents and ensure ethical deployment. Addressing these issues is crucial to balancing the benefits of automation with societal needs and ethical considerations. The future of advanced robotics and automation. The future of advanced robotics and automation promises immense innovation and growth across various sectors, with robots becoming increasingly intelligent, versatile, and capable. The integration of AI, machine learning, and robotics will enable unprecedented applications, such as swarm robotics for disaster response, environmental monitoring, and space exploration, including planetary colonization and complex scientific experiments. In healthcare, robotics and AI advancements could revolutionize personalized and precision medicine, aiding in disease diagnosis and treatment at an individual level. In agriculture, robots could promote sustainable farming, optimizing resources and minimizing environmental impact. However, realizing this potential necessitates addressing ethical and social challenges, ensuring that these technologies are developed and deployed responsibly with a focus on human well-being and societal benefit. In conclusion, advanced robotics and automation are transforming industries and shaping the future of work and society. These intelligent, dexterous, and autonomous machines offer significant benefits, including increased productivity, efficiency, and precision across various sectors. However, their development and deployment also raise important ethical and social concerns, such as job displacement, privacy, security, bias, and safety. To harness the full potential of advanced robotics and automation, it is essential to address these challenges through careful consideration, robust regulatory frameworks, and investment in education and training. By doing so, we can ensure that these technologies are used to enhance human capabilities, improve quality of life, and create a more sustainable and equitable future. The journey towards this future is a collaborative effort that requires the engagement of policymakers, industry leaders, researchers, and the public to navigate the complexities and opportunities presented by advanced robotics and automation. There you have it. If you found this video insightful, give it a thumbs up and share it with your friends. Don't forget to subscribe to our channel for more exciting insights into the latest technological advancements. Hit the bell icon to stay updated with our latest videos. Thanks for watching, and see you next time as we continue to explore the future of technology.